Hello, let's continue with what we were doing previously. We discussed how you come up with the reinforcement to a base. As you can still remember, using the various formulas that we did, we came out with the reinforcement. This is the same formula that you use for a cantilever. This part will be a bit on the cantilever side. So we calculated the moment, then we used the moment to calculate the reinforcement. Just a recap. Now let's move on to something else. Okay, now after we have used that moment, we calculate the K value, we calculate the lever arm, which is denoted by Z, then we find out the reinforcement, then we find out the minimum reinforcement. This is more than the minimum, we come up with that. Okay, now the most important thing that we need to do, sorry about that. Okay, now the next thing that we need to do is to calculate the shear values. There is what is called punching shear. This is when this column moves this area, which is 1,5 times the depth of the slab. The depth, by depth I mean this part here, from that point to that point. 1.5 of that depth from the face of the column might be forced to move in a downward direction, punching into the ground. This is called punching shear. So for you to do that, you need to calculate what is called the critical perimeter. Critical perimeter is this line that is denoted by this line here. So how do you do that? We know that there's a piece here which is D. Then if we add from that part to that part, we've got 1.5 D. That part to that part, we've got 1.5 D. So the 1.5 parts of D are 8. They are 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we've got the D, which is this side, that side, that side, and that side. Okay, which are the depth of the column, or the side of the column, which are about 400 according to the column size that we had in our calculation. It is based on that information that we use this formula. Critical column perimeter, this is the column perimeter, times 8 times D times 1.4. Now we come up with the perimeter here. Now when we have a perimeter, that perimeter that we have here, there is a force that there is an area within the perimeter. Okay, the area within the perimeter is the area within this thing. So it's going to be 1.5D, 1.5D, which is 3D, plus this one. Okay, so it's going to be 3D, which is this side, plus the column. Okay, then you square that, since it's a square, so you multiply this side and that side, then you come up with this area. It has been converted to meters. The reason why they did that is so that we are dealing with an area. We want to come up with this area on the outside here. So how do we do that? We calculate the area of this total. Still remember, it was 3 meters from that point to that point. So it's going to be 3 times 3. It's going to give us 9. Then we subtract this area that we have here. Then we come up with the area, with the net area, which is the shaded area here. That shaded area now is what we multiply with the force, with the shear force that is being applied there. Then we come up with this force here. This is the force that is moving in an upward direction, yet this part happens to be moving in a downward direction. So there's going to be shear at this face here. That shear is known as the punching shear. Now, so V, still remember V is the small v here is actually stress. It's going to be the force, which is the big V, which is this number that we're going to multiply by 10 to the power 3, so that we turn it to newtons per square millimeter. Then we divide it by the critical part. The critical part is the one that we calculated here. See, it's in millimeters here, so they used it in millimeters. It's the same number here. Okay, so the reason why they multiplied by this value, which is D, is because you still remember when we were calculating shear in our beam, which is linked somewhere there. Okay, when we were calculating shear of beams, the formula had to do with the depth of the beam. So this the depth of the beam in this case is the D, the depth of the slab. Okay, so that is why we multiply with this number. Then we come up with a value. The value that we come up with is this one. This is the stress that we have. Now we want to calculate the capacity of concrete to carry shear. How do we do that? It's the same as the beam. You say 100 AS, which is the reinforcement that we used here, which was about 230 if I'm not mistaken. Okay, it was 1050. Let's see. Here we came up with this number, right? This is the area that we came up with, the area of steel per meter. Okay, the reason why they chose to use this value here is because this was what they provided. Okay, let's see what they provided here. As you can see, they provided Y20 at 300. If you check from your table, the AS, the area of steel per meter, is this one. Okay, that is why you use the one that you provide for this calculation. So when you do that, you come up with this value here. Then if you have this value here, you take it to table 3.1 of BS8110. Then let me just go to that table. So this is the table, 100 AS by BD. Okay, so the number that you come up with was between these two numbers. Then the depth exceeded this one, so you used these two values here. These are the strength. It's somewhere between 0.35, 0.34 and 0.4. Okay, that is okay. Now, as you have seen in that table here, then you calculate the numbers there. Then this part is when you are converting the grade of concrete from grade 25 to 35, because the table was for grade 25. Okay, now once you do this, you come up with this shear value here. So this is the actual stress, this V. Then this is the amount of stress that it can resist. It means that this has passed, since this number is greater than this one. Okay, now after that, you go for what is called transverse shear. Transverse shear is the shear that will act in this far end part here. So how does that act? Okay, now we have an entire path, the entire width of the path, this part here. There's a force that is acting on this one. Okay, it's a part that is D away from the support, from the column. Okay, so the first thing is to calculate the area here. If you subtract this D, you come up with this remainder, which is 0.77. okay, let me just open up a calculator for you. Okay, so this is 0.77 meters. Then you multiply it by, from that point to that point, you multiply it by 3. So this is the area, which is 2.31 square meters. Okay, so you then multiply that area, these two numbers that I was talking about, they are this area now, with the soil bearing pressure, which is this value PS, which is, then you multiply this number with the 217 equals, then you come up with this value here. This is how they got the number. This number is the force that is acting on this part. Okay, so since this is the force, now you multiply it by 10 to the power 3 so that you change it to newtons per square millimeter. Then the next thing is to calculate the BD. The B is the breadth of the section, which is from that point to that point, which is 3 meters. Then the D is the depth of the section. Then you multiply these two, you come out with this shear here. Okay, now if you still remember, we already calculated the amount of shear that this can carry. Let me just go back a bit. Okay, it's 0.41 newtons per square millimeter. So this number that you come up with should be less than 0.41, which is exactly what it is, so it is safe. Okay, so that is how you calculate the transverse shear. Now you need to calculate if the column itself does not exceed the maximum shear that concrete can take. Now for that one, you use this number here, 0.8 square root FCU, that is the maximum shear that a concrete can carry. So directly under this column you need to check that the number is less than this one. Okay, once you've done that, but if you are actually designing an actual column, if this is exceeded in the column, then it means that you not have the column would have failed, it will be bigger. Now once you correct the column, this thing will automatically correct itself. Okay, now this is the part where you are just you're just annotating. This is the drawing, the way that you do the drawing. I will show you this in another tutorial, maybe a short one, so that we finish up. Thank you for your time. Please like, subscribe.